everyone, my name is Alma Chavarria, and today I will teach you how to name this given alkyl halide. I will be commonly referring to the IUPAC rules for alkane nomenclature, as they should always be considered when determining the name of a compound. So let's begin. Step 1 is to find and name the longest continuous carbon chain. Now, this particular compound is very interesting because there are 3 distinct paths that give the exact same number of continuously connected carbons, which will be 9. Path A is highlighted in pink, path B is highlighted in red, and path C is highlighted in blue. It is very important to start numbering from the end of the chain that gives the nearest substituent the lowest possible number, which is what I have done here. Now we need to determine which path to choose. In order to do so, we must skip to step 3 of the IUPAC rules and circle back to step 2 afterwards. Step 3 is to number the chain consecutively, which we have just done, starting at the end nearest a substituent group. Let's firstly look at path A. In path A, our nearest substituent group is this isopropyl group located on carbon 3. In path B, our nearest substituent group is a methyl group located on carbon 2. And in path C, the nearest substituent group is also a methyl group located on carbon 2. So in the case of B and C, where you have the exact same substituents located on the exact same number of carbon within the chain, you only should consider one of them. Arbitrarily, I would choose to consider path B. Now let's compare paths A and B. In path A, we get a nearest substituent located on carbon 3, which is higher than in path B, where we get a lowest substituent located on carbon 2. Therefore, we very well indeed choose path B to be our longest continuous carbon chain. Now circling back to step 2. Step 2 is to identify and name groups attached to this chain. On carbon 2, we have a 1 carbon substituent, which is called a methyl group. On carbon 3, we have a 2 carbon substituent, which is called an ethyl group. Finally, on carbon 6, we have an F, which represents a fluorine atom, and in nomenclature is written as fluoro. To review, we have a methyl substituent, an ethyl substituent, and a fluoro substituent. Step 4 is to designate the location of each substituent group by an appropriate number and name. We have already named our substituent, so all that's left to do is designate a locant to each one. The locant will be the number of carbon within the continuous carbon chain that the substituent is directly branching off of. The methyl substituent is directly branching off of this carbon, which is carbon 2. Therefore, the locant is 2, separated by 1 dash and no spaces. The ethyl group is branching off of carbon 3. Therefore, the locant is 3, and the fluorine atom is branching off of carbon 6. Therefore, the locant is 6. Finally, our last step, step 5, is to assemble the name, listing groups in alphabetical order using the full name. We are specifically alphabetizing the first letter of each of the substituents. So the alphabetical order will be E comes first, then F, and then M. Finally, we need to determine the parent chain name, which will be the suffix that always goes at the end of the nomenclature and is directly related to the number of carbons within the longest continuous carbon chain. In this case, that's 9. So it's called a no-name. Finally, we put everything together, going by alphabetical order. This should give us 3 ethyl, 6 fluoro, 2 methyl, no name. Each of the substituents are separated by 1 dash and no spaces, and the suffix goes right at the end, separated by no dash nor space. That gives us a final nomenclature of 3-ethyl, 6-fluoro, 2-methyl, no name. That's it for today. If you have any questions, please let me know. I look forward to teaching you something new in the future, and I hope you have a great day.